So in the second one, there's nothing we can really pull out of all three terms, so we need a different strategy. This is the one where we factor the quadratic by saying what two numbers add to the middle number and multiply to the last number. So we're looking to see what adds to negative 12 and multiplies to 20. Now notice you're multiplying to a positive and adding to a negative. That tells us both signs must be the same and they both must be subtraction. So we already know that. Then it's just a matter of thinking about ways I can multiply to 20. And the one that jumps out to me is 2 and 10. Because that's going to let me get the 12. You might have gone through a few others first, like you might have gone through 5 and 4 first or something like that. That's fine, but 10 and 2 ends up being the one that actually gives us the 12. And so this then is the actual factored form. Yes, we need the parentheses left in there. That's the whole point of factoring. All right, now one other thing that we did earlier this year is we did a lot of simplifying rationals that looked kind of big and ugly at first. Well, that's what we're going to be dealing with today. Is we're going to be simplifying rational expressions. Remember, rational expression just means big, ugly fraction. And we're going to simplify this rational expression, and others kind of like it today, except we're going to take the level up a little bit. Now remember, to reduce it, you're looking to see what can you divide out of every single term. In this case, there's two levels to that. We're going to start by looking at the numbers, 6, 15, 12, and 45. What can you divide all four of those by? 3. And so we're going to do that. We're going to divide every single term by 3. Then the other piece is we need to see what can I pull out of the x parts, the variables. Well, notice there are x's in every single term. The question is, how many can I pull out of all of them?
4.
And it's 4. Because when pulling out x's, I'm looking to see what's the fewest number in any given term, because then that's how many I can pull out of every term. So I'm going to be pulling out x to the 4th from every term as well. And when you do that, divide all the whole numbers by 3 and then pull x to the 4th out of every single term, this is what you'd be looking at as your final answer. So this is basically practice and review from what we did earlier this year, but the same principles that were involved in doing this are going to be involved in where we're going today. Because really the whole idea is we're looking to see what is multiplied into every single term. What is multiplied throughout the top and the bottom of this rational expression. Because if we can do that, then we can just extrapolate the exact same concepts to something that looks as ugly as this. Now this one is crazy as it looks at first. It's actually the exact same basic process as what we just did on the last one. I'm looking to see what is multiplied throughout the entire top and bottom that I can cancel out. Now the beautiful thing about this one that actually makes it, I think, easier than the last one we did is that everything on the top is multiplied together and everything on the bottom is multiplied together. The addition and subtraction you see taking place up here, it's all within parentheses that are multiplied. And so, for instance then, notice both the top and the bottom of this fraction have an x plus 8 multiplied into it. Because that x plus 8 is multiplied into both top and bottom, I can straight up cancel those out.
And the x minus 1.
That's all we have to do on this. So let's go ahead and proceed. Let's go ahead and find anything and everything else that we can go ahead and cancel out here. This x minus 1, does it have a partner on the bottom?
Uh-huh. Yes, it does.
Yes, it does. It's down here on the bottom right. So we cancel that out. The x minus 2, does it have a partner on the bottom?
No, but it's plus 2.
Well, there's an x plus 2 down here. Does that make a difference?
Uh-huh.
Yeah, it does make a difference. It means that we cannot actually cancel those out. They're two different because one is subtracting, the other one's adding. They're not alike enough to do anything with. The x plus 5, does it have a partner on the bottom?
Yep.
Yep, sure does. So those cancel out.
No.
So as you take a look at it, what we just have figured out is that we are going to be left with an x minus 2 on the top, and we will be left with an x plus the 2 on the bottom. But notice what I have not yet dealt with. I did not yet deal with the 15x to the 5th and the 25x cubed. And yet, isn't this actually just a simple version of what we just did on the last one?
Yeah.
What can I divide out of both 15 and 25? 5. So let's do that. So 15 divided by 5 is 3. 25 divided by 5 is 5. Okay?
Then the x's.
The last thing that I need to deal with here is the x's. The x to the 5th over x cubed. Now, remember, what that means is that means 5 x's all multiplied out together on the top, and 3 x's all multiplied out together on the bottom. So if I'm going to start canceling out anything that appears on both the top and the bottom, I can cancel out 3 pairs of x's, leaving me with how many x's? 2. And where are those 2 x's? On the top or the bottom? They're on the top because the x to the 5th is the bigger one, and that's on the top. We have more x's on the top. So that means 2 x's, that's x times x, so it's x squared on the top. This is the simplified form of this. And basically, everything else we do today is just riffing off of this idea. Nice and easy stuff on the horizon. It just looks really complicated when you first see it. Like when you first saw this problem, I know many of you were like, oh, that is just wrong. But was it really hard? No. It just looks complex. And really, that's the point, is we're seeing how can we simplify these things so that they no longer look quite as crazy. All right, so as we take a look at simplifying this, remember I can cancel out anything that's multiplied throughout the top and the bottom. Great. Does that mean I can go ahead and cancel the x squareds? Well, can I divide every single term on both the top and the bottom by x squared?
Of course.
No.
No.
And since I cannot divide every term by x squared, I cannot simply cancel the x squareds. And so, you know, when we do this, the addition is making it tougher, right? Because I have to look at all 6 terms and see what can divide out of them. So what we're going to do is we're going to get rid of the addition by factoring it. Because notice, the top is just a little quadratic. It's factorable. So if I'm going to factor the top, I need to figure out what 2 numbers add to 5 and multiply to 6. That'd be 2 and 3, yeah. So that top is going to become x plus 2 times x plus 3. Notice, instead of a bunch of stuff added, now I have a bunch of stuff multiplied, which means I'm probably going to be able to simplify something. And so, as you might expect, factor the bottom as well. And so when we factor the bottom, then we got x plus 5 times x plus 2. Okay, now this, having done that, this looks like a very simple version of the last one we did, doesn't it? The last one was a big crazy one, but this one just has 2 sets of parentheses. But again, we attack it the same way. What can we cancel out of both the top and the bottom? The x plus 2's go away. And so all we're left with is x plus 3 on the top and x plus 5 on the bottom. And then we're done. There's nothing else we can do to this because, again, notice, there's nothing I can divide out of all 4 terms. And since there's nothing I can divide out of all 4 terms, there's nothing I can do else to reduce it. All right, so after factoring and then cancel out anything that's multiplied in both top and bottom, we end up with just x minus 3 over x plus 3. Can we simplify that at all? We can apply these same kinds of techniques to more involved problems, problems that maybe have operations going on in them, such as this, where we're going to be multiplying the rational expressions. All right, so now in order to do this one, we're going to be multiplying our fractions. Remember, to multiply fractions, we just go straight across the top, straight across the bottom, right? But we have an option in front of us, and we have a choice to make. I can either leave it all in factored form. So I can go x plus 7, x minus 3, all over x minus 4, x plus 7. So that's multiplying them together but leaving them in factored form. Or I can expand them out, which would give me x squared plus 4x minus 21 over x squared plus 3x minus 28. Which of those two forms looks like it's going to be more useful to us?
The first?
Well, seeing as how we're going to be trying to reduce it, this one's going to be better. Because if I gave you this one on the right, your very first step in simplifying it would be that you would have to factor it. So while you can go ahead and expand it out, the first thing you'd have to do is refactor it. So don't worry about expanding. Just leave it in the factored forms. Because then we can go ahead and reduce it. And you'll notice here, I see an x plus 7 in both the top and the bottom. So those are going to cancel out, leaving you just with x minus 3 over x minus 4.
Yay!
And there's nothing else we can do to reduce that, so we're done. This is going to be the most complicated type of problem that you'll be seeing. We'll work through it together, but really the process is all stuff we already know. It's just a matter of having to do all the work along the way. All right, now, as we start working this problem, step 1, what I always want you to do at the start of doing any of these problems, factor anything that you can factor. In this case, what makes this problem harder than some of them, outside of just the volume of writing, is the fact that you actually have 4 different quadratics to factor. Now, thankfully, they're all fairly straightforward to factor. The numbers aren't too big, but we still do have to go through the work of factoring them. All right, so first step was to factor everything as much as we could. We've done that now. Now, we can focus on what operation is taking place. In this case, it is a division problem. How do we divide fractions? We flip it and multiply. Yep, we multiply by the reciprocal if you want to be extra fancy about it. And so the very next thing I do is I rewrite it, leaving the first fraction the same, but flipping the second fraction and turning it into multiplication. And yes, I do want you to write out this step. I will inevitably see somebody who tries to cut some corners in here, and they'll try to like go straight from here to here and leave off that intermediate line or something like that. But part of the reason why I often see it is because I'm called over to help them find their mistake. Whenever you do that, whenever you skip a step with these, it's too easy to lose track of what goes where and to get something in the wrong spot. So by all means, on these especially, write out all the steps. I know it's a lot of writing, but it seriously is going to save you a lot of trouble. And now that we've written it as multiplication, we're going to do the multiplication. Now thankfully, multiplying fractions is super easy. You just multiply straight across the top and straight across the bottom. And with all these parentheses here, we want to leave the parentheses in there. So it's not like I got to multiply it all out. I'm just going to end up with all 4 parentheses on the top and all 4 parentheses on the bottom, basically all just lined up together. And then once we've created a single fraction, we can simplify that one fraction, canceling out pairs that appear in both the top and the bottom to get our final answer here of just x minus 8 over x minus 7. That is your final answer.